Gandhi sir, am I audible to you?
Yeah, I'm okay. I'm audible.
Yes, audible,
Yes,
sir.
yes, sir.
Okay.
Yes. Good morning, all the participants. Uh, our first session will be conducted by Jayesh Gandhi sir. It will be on industrial IoT. He belongs to Harikrupa Automation Private Limited, which is an IoT-based solution provider company focused on innovative utility solutions. Currently, Jayesh Gandhi sir is heading the design and execution of smart electrical automation and process automation projects. He has done BE Electrical and he is having 35 plus years of experience in this field. So we welcome you, sir. Now
Thank
session
you.
is over to you. Yes, sir.
Yeah, good morning, everyone. Yeah, today's session, what I'm supposed to deliver is importance of IoT in energy. Uh, just for first few minutes, I will just share with you. Everyone is now aware about what is IoT, how IoT is playing vital role in today's automation or centralization of data. Few years before, no, it was very difficult to centralize uh, thousands or lakhs of sensors on common platform. Now, everyone is aware about that. While no, the need of a smart city. So when the smart city was thought of in year 2013-14, if I am correct, in Australia first and thereafter in USA. So during those days, no, everyone was no, envisaging that in smart city, what should be covered. So once no, there is a city, there are all utilities are no basic need for comfort of the citizen. So in that case, it has been thought of that smart street light management, smart water management, smart affluent management, smart solid waste management, and smart energy distribution management. So such 5 or 7 key aspects was considered that these are to be covered under smart city solution. So in that case, when design was progressing, that how it can be centralized, then they could reach to lakhs of parameters which are supposed to be pushed from all system to central server. So at that time, things has been thought of that you people, everyone know, all engineers are know understanding that each server has limited ports, and with that reason, no, the it can receive no, and each port can receive few numbers of data at a time. So the thought have been put that no, what the technology is more suitable for such application where there are numerous solutions which are concurrently connected to the central control loom. So just I'm adding few a very important part which is part of the smart city solution is surveillance part. Okay. So surveillance part and traffic management and so many things are covered in the central control room. So how to have all concurrent data simultaneously in the control room. So at the time, the everybody were concluded that in such situations, the IoT is the best solution. Reason is that IoT device is pushing the data first. Second, it has a publish subscribe methodology and having MQTT protocol. So the best advantage of MQTT protocol is that even no lakhs of data is pushed. So data is first, that is, it is at root level, it is timestamp punched, okay, real timestamp punched at the root level. So it is tagged with the all parameters tagged with the real time, and then it is device is pushing the data to the central control room. Another part that the MQTT protocol is queuing the data as per the timestamp, and it is inserting the data in the database as per the timestamp, and that too also without losing on data. So there is no congestion is affected because it is a publish subscribe mode, and it is the converted into the queue, and henceforth the data availability at central control room is more than 99.99%. And that too also that the server requirement is also reduced because the data is queued, and henceforth the load on the server, concurrent load on the server is reduced. So in this case, the main advantage is server requirement is reduced, and with that the lacks of sensors or systems are pushing the data at central control room. So in this, as I described, that water system and all whatnot, smart energy, smart streetlight management, surveillance, everything has been centralized. Let's say first in the Australia and then simultaneously in the US, and with the IoT protocol, and with that, it has been found successful. So in India, if I'm correct, the acceptance has started 2 to 3 years before. So we just accepted this in 2017 and 16-17, and really speaking, since last 2 years, all my friends who are listening me are they can also confess that IoT, that's okay. It is 2014 edition where it become popular for the smart city solution applications, but in India the acceptance has started in 16-17. So in this regard, so we is a Hari Krupa Automation Private Limited company. We started in 16-17. We started 10 years before, but we started focusing on this IoT and the cloud centralization system, cloud-based, in 17-18, and we have done many applications on this, and mainly on the smart energy. So I will start with presentation, small presentation, and in between we will go to the in my presentation there will be some case study, and at some point we will go to the live system also to understand how IoT is good, and it is making the normal conventional things to the smart. Now everyone knows what is smart. When someone was talking about this smart, then it is understood that the system itself is giving what is needed without any manual intervention. So manual intervention is minimized with this smartness of the system, and if you go back, there were smart transmitters, smart sensors. So in that case, everything was auto calibration and auto error detections, and that it itself is giving the deviation of the measurements, and so many things have been introduced in the smart sensors in the past. So similarly, now the solution became smart. So the whatever the terminal objective and KRA, what has been envisaged while designing the solutions, they should provide all KRA or KPI for the solution at very, very minimum manual intervention. That is the main objective of the smart solutions. So we'll be talking on mainly on the smart energy. So we'll start with the smart energy. And in that, smart energy has mainly two. Today's everyone is talking about the conventional energy, and another is the renewable energy. So whenever conventional energy is distributed, is it? I hope everyone can just see my slide.
Yes, sir, it is visible.
Yeah. So here you can see that the Harikrupa logo is there, and below that the logo has a punchline of IoT energy innovation. So this logo, we started our company in 2010 so far, but we changed. When we started our company, the punchline was IT enable automation, and in 2017, when we started focusing on IoT based solutions, we had changed our logo to IoT energy innovation. So we in this case, the IoT energy, enable energy is now they mainly we are working for the smart grid and smart renewable energy solutions. So this presentation, we may be breaking it sometime for the real time solution, and in this case we can start with what are the where we are presenting. So mostly if we start talking about the smart solutions, then it is in water, gas, electricity. It may be home, office, hotel, hospitals. Now when I was talking about the smart city, part of the smart city solution is smart building. That is very key important. Here we can see that these offices and hospitals and even smart parking is also part of the smart city solution. So these are all the part of it. And very important part today, everybody is talking about the environment solution. That is a affluent. We are today, the smart pole we are seeing. If we go to Gandhinagar, that is a certain distance there are smart pole which is showing what is the situation, temperature, humidity, and what is the emission level, what is the affluent in the air. Now another very key important part is the smart renewable energy, where solar, wind, and biomass is also playing vital role. Then in industry, that's networking, monitoring, and control. Then lighting solution, street light and hoardings. Then we talk of the energy management solution. It's a building energy management solution, industry energy management solution, home energy management solutions, and infrastructure solution. That's the building, cell tower, and the toll booths. So coming to the smart solutions, we could get the opportunity to walk around all solutions, which I just see importance why I am displaying this. Today's subject is the case studies regarding the IoT based smart energy solution or smart solutions, and henceforth I am displaying that we might have contributed by now the only 3% of the possible solution in India. So even 3% if I talk, the IoT based smart rooftops RMS remote monitoring system we have done across 500 plus. Then IoT solar pumps remote monitoring systems what we have provided in Gujarat and Rajasthan more than 1500. Then that's again in renewable energy, IoT solar megawatt plants. We could cover 200 megawatt across India. Then smart grid. Smart grid is a very important area in the energy, and it is playing vital role in this energy distribution. So we will come to that. It is a very important area, and it is growing very fast. It is as good as the smart water distribution system. So water is a commodity for the citizen of the city. Similarly, energy is very essential requirement for the citizens. So both are today every city would like to have smart energy distribution, smart water distribution, and smart street light management solutions. So next, what we could cover, the Gujarat, almost 33 cities of Gujarat, we could cover with the IoT street light management system. That is a centralized control monitoring system, CCMS systems for 33 towns. Similarly, we could cover the smart home also and smart building also. So we could cover more than 2,000 location for this smart home and smart building. And as I said very correctly, that water is also a very essential commodity. We could do that is for industry as well as for the residents. So we could cover 500 plus locations in Gujarat and Rajasthan for the smart water distribution management system. Now, industrial IoT, energy domain, and innovative solutions. That is, we have taken the paths to provide our smart solutions. These are the advantage of this smart system. It reduces the operating cost, energy consumption, downtime, and deriving performance indicator. Now, we are more focusing on the deriving performance indicator. Whoever is not spending money for the solutions, they expect. I repeatedly saying that when solution has to be smart enough that whatever performance indicator, that's a key performance KPI, key performance indicator, what is necessary out of this solution should be having minimum manual intervention. So this is a very important part, and it's part of the analytic of the software. So it's a part is dashboard and analytics, notification is for the safety, alarm, and all that comes. That's a part of the solution. It has to reduce the downtime. Then how it can reduce the downtime? Any system, if we are getting the diagnostics well in advance, that is before the system collapse, if you are getting the all error code or diagnostic messages, then you can address your maintenance prior to the system collapse. So that indirectly, that it's very much important for the reduction in downtime of the system. Now, in-depth monitoring, so that is a reduction in maintenance. That is so many conditioning monitoring analysis or the data you have in advance. Then speedy fault detection. This is very, very important. I may be able to describe it in detail when we go to the system, like in smart street light management system and many more systems that now everyone wants. I take a small point for the street light management, because everyone is aware about the street light. So go back the 5 years before that the street light management, the maintenance was accepted within 3 days. If it is attended, it has been said that it is satisfactory maintenance services. Now today, that street light management system, when we go to our live system, it is giving the all diagnostics and detection of the non-availability of the street light within 10-15 minutes, and mostly within 2 hours it is attended. So you can understand that how expectation has changed. Previously 3 days means 72 hours was okay. If street light is attended within 72 hours. Now the expectation is that any information about the non-availability of the street light has to be within 2 hours or even 15 minutes, and to be attended within 2 to 4 hours. So you can say that it is now it is previously 100%, then today within the 5% time is provided to address the resolution of the problems. So that expectation has increased, so the system smartness has to be improved. Anyway, these are our case studies. One of the case studies, that I may not be covering, so I'm putting here. You people might be aware of the Cyberome and Sophos, and that this company is morely in the cyber security. So they have firewalls, and Sophos is German-made company, okay, and they are in Ahmedabad, and they have 2 buildings. So both the buildings, we have made smart building 4-5 years before, and still it is in use. So with the IoT, this as I said, the notification and everything is self-declared, and it is that the sensor itself pushes the notifications. And one or two small points, because I may not be covering this smart building in this today's session. So in smart building, 2 or 3, there are many more points that a smart building covers. But for conventional part, that is, I will talking about that if there is a building, then there is always there is maintenance manpower is available is not possible, and these buildings are operated 24/7. So very critical is lighting. Okay. So here, within the building, what is provided that even any MCB trips, then it enunciate, it pushes the message on the mobile or on server or any maintenance node that floor number 1 that is a distribution box number 7, MCB number 5 tripped. So at night only security persons are available. He can have this notification. He can reach to the floor 1, then distribution number 7, box number 7, and he can see that the MCB number 3 is tripped or not. If it is tripped, he can switch it on, and he can stand for that for a few minutes, that whether it repeats or not. Okay. Or if it repeats, then he can keep open the distribution board to hit dissipations. And fortunately, we have provided temperature monitoring of the distribution box also. Okay. So with distribution board temperature also, he can rush to the place and he can open the distribution board, and so that the inside temperature cannot reach to the fire ignition level. Okay. So the building itself is in so many things within, even air conditioning system. That is the IDU, itself is passing the message error code. There actually Daikin IDUs are there. That's air conditioning system is there. So if filter is short or something wrong is happening, fan is not working, many more things are not working within the Daikin system, then we have converted into smart, and the Daikin Service Center receives through our system, that's the IoT cloud system, that so and so floor, this number of the IDU having filter choke problem, and the defect is logged with that system, and defect is logged within the maintenance logging system of the building. So similarly, so many things. I will not stop here for more time, but I am not supposed to cover this. So just I have put up some time over here. Otherwise, there are many more systems where we have provided, and these are all. But I will come to the next. That too. I will go fast because previously what I believe that some of the things has been covered from my previous speaker from my company. So here is nothing but the in total in smart solution we need to have IoT device, and we need to have some cloud-based IoT SCADA or some solutions, and we should have some analytical platform. So here you can see that what is this IoT energy the platform, which connects the multiple sensor and devices, communicate over the thousands of kilometers, and compute millions of parameters, and manage thousands of devices, analyzing using the Intelligraph as an analytic software. And henceforth, this solution became smart using this, the different hardware, software, and analytical modules. Now, I'll again go fast because this Intellimon is our own product brand, and it has all facility. That is, it can sense analog, discrete pulse, and discrete output. Also, it can give any humidity, even luminaries, temperature, pressure. So many things it can sense. The sensor itself can sense, and it is intelligent, and it is connecting directly to the IoT SCADA platform. That is it is having all modules, which is necessary for processing and for computation, and it is again, it is using many more software modules for analytical purpose and analysis purpose. Now, okay, smart system again. That's what is being considered. Smart system incorporate functions of sensing, actuation, and control in order to describe and analyze the situation and make decision based on the available data in a predictive and adaptive manner, and thereby performing the smart actions. So I will not go much on that. So what is smart action? So everybody is aware about that. The smart action is the best of best actions, which is derived out of the experience. Okay, and that is said to be smart action and smart action. So there is a small difference in between. Now, I will just, as I say, the main part of this session is smart energy. Okay. Now, smart energy is today, the two, one is conventional, another is renewable energy, and any energy, the distribution, is very complex, and in that case, how to make distribution smart, and henceforth, the downtime is reduced and customer comfort is increased with the availability of the energy supply. So now coming to the smart grid, and what is the definition of the smart grid? That's the definition by National Institute of Standards and Technology, that is NIST, USA. What they define, that's a modernized grid that enables bidirectional flow of energy and uses two-way communication and control capability that will lead to an array of new functionality and applications. So ultimately, the NIST has provided the definition of the smart grid to improve, as I described, the availability of the supply and reduce the outages. Now, IEEE smart grid, what they say, smart grid is a large system of systems where each functional domain consists of 3 layers. What is that? The power and energy layer, the communication layer, and the IT and computer layer. Now, layer 2 and 3 above are the enabling the infrastructure that makes the existing power and energy infrastructure smarter. Now, this is something that is the international standard for smart grid and distributed energy resource. So here, the smart grid, that's the distributed energy resource, the DER, IEEE standards have been formed. The IEEE 1547-2018, what the standard talk about. The revisions specifies a mandatory, standardized, and open DER communication interface. In addition to the electrical performance of the DER at its electrical connection point, the new DER capability requirement includes. Now, what is new? Why new DER have been formed? Because they would like to have, add this smartness in the grid. So I will not describe, but they would like to improvement in power quality, then emergency shutdown, and active power curtailment. Now, smart grid Indian scenarios, if we talk about, then 38 gigawatt solar rooftop to come up. and that is equal to nothing but the 2,50,000 solar rooftop, more than. Okay, so you can understand. I don't know that you people are not mostly from energy, but just for your information, whenever see what the power we are getting at home is something that is it is from the grid, that distribution power, and the same power is available everywhere in the city what you are getting, or even the nearby city also. So there is a grid, and in that case, in 5 years before, it has never been thought of that there will be see what is solar plant. Solar plants are nothing but they are generator as good as you may be seeing that so many power plant, Sabarmati power plant or Wanakbori power plant or Gandhinagar power plant. There are so many power plants which are commonly supplying the power on the grid, and we are getting from the grid. So today we may be thinking, no, this if we go back 2005 to 2010, there were only, Gujarat, total Gujarat was power was sourced from the only 40 to 50 power generators. Now just think of that in new scenario, that is the distributed energy resource scenario, the power will be added on the grid from rooftop, wind power, or so many, and that too in the quantity of lakhs of quantity. You can see that it's 2 lakhs instead of 50. Now 2,50,000 solar rooftop, and you can see that is a this is a 10 lakhs solar pumps may be coming, and EV charging vehicle is also coming up. So they are acting also generating source also. And so many energy stations, storage stations will come up, and it has started as a battery energy storage, and what will be utilized for the emergency requirement at the hospitals or many buildings, and in the cities also for the surveillance purpose also. So this is again what I discussed. The same things you can see here. There is a incoming smart building. Then everything, there's a car parking, smart electrical vehicle charging, and smart control and smart. So everything, after 2005, 2010, things, expectation became, let every equipment be smart, let it declares their troubles, diagnostics, and in some of the cases, the smart, if people are from the smart IT, many of the you people are. So in server, that's a auto recovery. Okay, similar way that auto restoration in electrical equipment also been envisaged in 2010-15, and you may be seeing here smart meter. Okay, so that is smart energy distribution. When talk of that's smart meter, Ahmedabad we have not received. Okay, but it's supposed to come. That it's a out, and that's a, they can disconnect your power sitting at their control room. Even they can have data, continuous data from your energy at their central place. So there's a smart generation, transmission, distribution, residential buildings, and all. And smart parking and energy storage. This is this has already been come up in the smart city. Okay, Ahmedabad is a smart city, but till we have not received this. But as I said, in Australia and US, when it was thought of, that is the smart city solutions, they thought of everything what has been shown in this slide. Now here, that is again, smart grid is nothing but the smart energy distribution system. So there are many devices and many components. So that's equipments, transformer, and all the equipments are there. And you need multiple functionality. That is, you would like to have automatic meter reading without going to the place. You would like to read the energy. Then you would like to have energy audit. And a very key important area today is expected by all energy heads, that is even cabinet secretary and all. they are focusing on the losses, there's energy losses. So if you cannot measure, you cannot analyze. If you cannot analyze, then you cannot identify the losses. So in smart distribution system, one of the key expectation is that is energy measurement at all the points from where it is flowing. Okay. So again, as I said, there's multiple stakeholders are there. That is a DISCOM, then different companies, renewable energy. So different, even load centers are there. So now the complexity is this. Now what I'm before going to the solution, if you understand the complexity of the problem, or solutions, you can design solution. If you understand the complexity, if you don't understand the complexity, you cannot design the right solutions. And henceforth, the complexity has to be understood prior to design the solutions. Okay. Similarly, these are again multiple softwares, multiple protocols, multiple agencies, and multiple projects are running in this field. Now, this is something I will not go much in depth because you people may be saturated with what is this smart grid and smart distribution. So I'll be just some key KPIs. That is, what is the KPI? These are the issues. So KPIs are this interoperability, maintainability, difficulty in decision making, and henceforth we need to have the key objectives or KPI out of designing the smart IoT-based smart solution for the smart grid. What are those? That is, first is the maximum uptime. That means if you are a user of energy, then you always think that power should not go because it creates uncomfort. Okay, so anything, the maximum uptime. If you sense early, you can act early. But if you sense late, you can act late. Second, one is part sense. Another is if you can analyze the right fault at early time, you can act faster with the pinpoint solution. Third, if your sensor and system is smart, then it provides the right solution rather than the defect. It will provide the action what is to be done rather than what is the problem existing at the moment. So these are all gives the which heals the system, will recover the system very fast. So improve the operational efficiency, technical losses, commercial losses, so improve availability, reduction in losses, consumer satisfaction. That's very, very important. I'll talk about the smart energy. The time will come that the distribution company has to pay penalty if they are not controlling their interruption of the power and duration of the interruption. If they cannot control, then they cannot charge electricity at this standard rate. That type of the norms is supposed to come up soon now. Now, the better stability of the system is also very important. So again, improve availability, reduction in loss, consumer satisfaction, and stable systems is the expectation of these smart power distribution systems. Now, I think you people will be able to appreciate that what the protocol is used. So this is a Modbus become more standard protocol, and this device is, as I said, the IoT device is the expectation is they should be that's a port communication, then Ethernet, then 485. We should have wireless communication like Wi-Fi, GPRS, RF, like LoRa. So many more things have been attended now, and here that is it should have the various TCP/IP, Modbus, or HTTP, Modbus over MQTT, JSON, and applications. So these are all now the standard IoT protocol have been now envisaged, and field sensing are analog, digital output, relay output for the commands. Now, these are this device. The IoT device. One of the key functions expected is edge computing. Okay. So as I repeatedly saying that device and sensor itself should be smart, that it gives the action or it acts also. It gives the actionable output also, or it many of the cases it acts by itself to resolve the problems. Okay. So edge computing is very important in IoT devices, and it is having embedded intelligence also, and ultimately, the cloud-based system. So it is a single platform having multiple functions. Again, that here that is the measurement and monitoring, audit analysis, smart control, production operation, and which is equal to smart grid. What I have discussed is concluded here in one slide actually. Now we'll be talking about the from where we receive the power, how power is controlled. So there also the expectation is measurement and monitoring, audit analysis, smart control for technical loss reduction, protections and operations. Now this is something that I'm not sure that everything is visible to you, but mostly you will be able to see the components and may not be able to or may be able to read also. So here we can start that these are the smart IoT devices which are in the some breaker compartment, switching compartment, and it is sensing all requirements, that is analog as a power, voltage, energy, current, power factor, and all digital inputs, and it is reaching to the smart panel. Okay, and it has the local control is it has that's a lens SCADA. Okay, and for the remote cloud purpose, it has a GPRS connectivity, Wi-Fi connectivity, and it is connected to the IntelliSCADA and IntelliGraph at cloud level, and it is also connected to the directly through this panel also, or through cloud also with the smartphone. So one of the advantage that if data is not flowing to the cloud from this place, then this device can directly connect to the smartphone, and through web browser you have all data, all information. You can do some command action from the smartphone also. Okay, so this is a basic architecture for the feeder management system, and what the data you are getting. You may not be very serious on this part. So ultimately on mobile also you have all these informations, that is status and parameter information, and you have on laptop or at central server or SCADA also. This is for the monitoring purpose. You have trend and pattern analysis also. Very key important part in this is today everyone would like to have a fast maintenance systems. Okay, so in this it's a this is something that whatever we are seeing on geography. Okay, in geotagging is there, and each point is nothing but the large size of the substations, which is scattering more than 4, 5 or 10 villages, and maybe 100 of industries. So each point is providing power to more than 2,000 locations. Okay, so how this it is controlled, monitored, and centralized for the better performance, improvement in the performance. You can see here that each is geotagging. Okay, the second part is it is a color change. That's you may be seeing here. This cursor is legible, or cursor never be? Okay. Cursor. Yeah.
Just say that red color.
Okay, so that we have cursor. You can see it. Just a minute, please. You know that how cursor is selected? Red cursor.
Pointer on
Sachin. If he is free. Yeah. Hello. Hello. Cursor. Cursor.
ग्रे कलर में पॉइंटर लगा हुआ है पेंसिल पेंसिल हाँ पेंसिल इस पे क्लिक करने पर लेगा पॉइंटर
Okay.
ओके
Hello. Hello.
Yes, sir. Now it is visible.
Okay. Yeah, yes. Sorry, I could not actually. I was thinking that wherever I am moving my cursor, you could see it, but just suddenly I thought of let me confirm it. So I think no, this is all geotagged distribution substations, and you may be seeing no that somewhere is Vijapur, somewhere is Visnagar, and somewhere is Meshana, and no, they are so far distributed long because each substation and wherever the abnormal is there, in which feeder there is a problem, and this problem duration is this much time, but
Hello, Gandhi sir. Gandhi sir might have some network issue. He will be joining soon. Am I audible to other participants?
Yes, sir.
Yes, sir.
Okay, let us wait for 2 to 3 minutes. I am trying to reach Gandhi sir.
Okay, sir. Okay, sir.
Gandhi sir is on call. He is going to join us soon.
Hello.
Yes, sir. Yes, sir.
We were connected or
Yes, sir. You are audible. You are connected.
continuous connected?
No, sir.
Okay, okay. Cool.
It was disconnected.
How long? Hello?
Sir, voice is not audible properly.
Yes, you could have interrupted it told us actually. Yeah, now since hello.
Yes, sir.
Shall we go?
Yes, sir. Yes, sir.
Okay. Live demonstration everyone could see, or we were not connected during that time?
No, sir. It was not connected. Sir, you were disconnected.
Okay, throughout the case study, there's a live demonstration was not there.
No, sir.
Okay, so we thought that, but you could have told me actually,
Sir,
that we are connected, and so live. Actually, we connected to the live system. Live system actually we connected to the live system, and since last 15 minutes we were just going through the live demonstration actually.
Okay.
So no one could see the live demonstration.
No, sir.
Okay, so would you like to go through live demonstration again for 10 minutes?
Yes, sir. Please.
Okay. Go for live demonstration.
Screen is visible, sir? Sir, screen is visible?
No, sir.
Hello?
Okay.
Just a second.
Screen is yet not visible.
Now?
Yes, sir. It is visible.
Visible now?
Yes, sir. Yes, sir.
Okay, then yes. Okay, so really sorry that actually we thought that we are connected and we were talking on the live demonstration. So you are requested to at least knock the things. Okay. So now Hardik is with me, and he will just explain how actually live this system.
As you see here, we have connected 6 substation over here, and data we are receiving here. So you can see live, and it is pushing the data, and the device is synced with the server on a last timestamp, that is 11:52, right? That is a bus voltage we are capturing here, and that's that feeder status. As you can see that the feeder which has been since last from 1 hour and 47 minutes. So operator can directly have the notification script in these substations. So same way you can see over the out of 6 substations, one is having the red blinking. So that operator can directly identify that this substation is having a problem. So on a click on the that geo pointer, you can see one AG feeder is Okay. So you can click over there. You can see that which feeder is got tripped here. So same way, feeder status in a single dashboard. And now we will talk about that losses dashboard for the losses. Here you can see that 56 megawatt units is received in a substations and 55.53 megawatt units sent out from the substations. So here you can see that the transformer losses. The transformer losses is the 0.71% and that bus losses is the 0.31%. So transformer loss is nothing but that is the incoming power to outgoing power.
Yeah, so here there is one part that you can see the losses of the equipment online, and it is being calculated and we have advantage to have corrective action on that. Second very important part, what I was talking, that to be improved, and that is the expectation of the Central Electricity Authority, and they would like to understand that what is the interruption in your system. So the interruption here, total interruption is 10, the 3 plus 7. So and there sustain is there something that is the interruption is more than 15 minutes or something, and transient means the interruption has come but it is restored automatically duration time. So coming to the right point, that's the system, this IoT cloud-based system, the centralization is very much possible, and you could have seen in the geography that each one is a city, the Vijayapur or many more cities, and are displayed on the map, and that can be the abnormality is seen by the color change. Second part, the non-availability, then what is the interruption of the fold, that is all being done without any manual intervention. So system is with this we can have quick restoration. Another part that you can have single line diagram also. The how power is flowing or power is interrupted. Single line diagram. Yes, so here even actual there is power is received, then further power is on the bus, this transformer parameters, breaker, once it is green it is closed, the power is flowing through, and where power is flowing, and how is the system. So one can go in with the diagram also. Okay. Now coming to the point that as I said that we are not go in detail that what is being done, but ultimately the benefit of the IoT and cloud for smart power distributions. We are one of the key important point that these all things one can see in the mobile. The operator is even the concerned in charge engineer of this for all substations also can see, and he can remotely he can see wherever he has also notification with the fault, and he can advise the local person to restore. So these are all the advantage of this. Next, yeah. So we can come to the presentation again. Photographs. Install करूँ.
हाँ यार, पहले बता.
Okay. Presentation. Okay. So this is clear now, and these are
pencil image. Third one is red one.
So this is static. We just what we line. This is something part of presentation. Okay, and here again, what we would like to application, but we will not be going in detail. Some of you may be having understanding that reactive power. If reactive power is more, it reduces losses, and how to improve the reactive power in the smart grid. So this is for recent solution which has been provided, and which has reduced the losses in the system to the tune of. So this is again reports and outcome. These are the KPIs. There's operations and we done out of using these IoT-based reactive power management. So use saving is being done with this, and this is something that you can see the analysis, but I will not explain what is happening, and henceforth the saving is achieved. This is further, that is one of the so again, that's you might have seen the transformer, distribution transformer close by to your residence. There, with the IoT, the normal transformers are now connected into the smart distribution transformer. Detects the theft, which detects the overload, which detects the short circuit in the power distribution. So you might have heard of this. I think 6 months before or sometime in Surat, one of the building where tuition classes was in use. Okay. So now IoT, with the use of the IoT, the transformer can be smart, and it can distribution also, and it trips the power to the short circuit part also. So what we have already done at two such cases, IoT-based smart transformer systems. So again, in that case also again, you can. The protections are embedded, its intelligence is embedded, all smart action is embedded within the IoT device. So there is nothing to receive. It acts and it clear codes. So everything is being done locally. So this is very important. What has been derived with the use of the IoT. Now, yeah, audible. It is audible to all. Hello?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yeah, sorry. Yeah, please, because
Yes, sir.
that. Yeah. So that is you might have seen the transformer. So in this box, the IoT device and all everything control system within this box. So it is extended system is embedded. Something it's the unique solutions which is developed, and it got the. So you can see that conventional transformer will not have this portion, but here this portion, through this portion, this power is flowing RYB and neutral. And as I described earlier, this senses the overload, this senses is the abnormality in the power, and even though that this system takes the decision by to remotely through the cloud SCADA at a central place, and if somebody would like to disconnect from that place, they can disconnect. So IoT, no, this as I said, no, it is appreciated, and okay. So this is something, you know, everyone knows that, no, the even though I would like to power into single phase power, it can be converted with scheduled, and second, that it can be done from the remote also. Even you can connect and disconnect remotely. Overload and all protection. This is what the smart transformer. That is what I wanted to know. Explain you about the utilized for this purpose. Now, with this, another part is there, but what I will do, that's I hope that we have second session 2 o'clock or somewhere, and so I would like to keep few minutes for the question answer sessions.
Sir,
Yeah, please.
this question may seem a little just wanted to ask, sir, this time, like say in Mumbai, there was a big power failure.
Yeah, you said correct.
Yeah. So,
Yeah.
could this
There is
kind
a
of
power
system not help in such kind of problems or predict something like this?
Definitely, it will help. See, just I will show that in general how power failure occurs actually. Okay, and this power failure is this system definitely help a lot, and it can prevent also from such cascaded power failure. Let me brief that how such power failure is happening. So you might have seen some, no, that's I explained that distribution transformer or later part. It affects, no, distribution transformer will be overloaded and it will affect the substation, may affect the generating plant. Okay, so if distribution transformer is isolated from the fault, then the other system is revived. So if smart distribution is there, then distribution transformer has to clear the fault and further system is safeguarded. But if it is not that, then it will the fault will be transferred to higher and higher places. That is one part. So I'm putting up a smooth transformer is one of the key devices. Similarly, there will be few receiving stations also, substations are also there, where directly and from there it is transferred, and at that time what, and there is a fault. I repeat, there is a fault. What is fault? Fault is always more current to flow to the fault. And hence, it is loading the system. And at that time, some plant is tripped, suppose. Okay. What will happen? Frequency will go down. Okay. And we, at home, we are getting 50 Hertz frequency. To load, it is reduced to 48.5. Then plant will be not synchronized. So, where fault is there and if it is cleared is one part. Second, such system has to have a centralized system. Then remotely you can isolate the system. Second, when you are restoring the system, this is the fault area, let it be isolated, and I should start powering. So one is the probability is 25 to 50%. Second part is restoration time. Then restoration, if it has taken 2 hours or 3 hours, it could have been restored within 1 hour. So as I described now, the smart grid and smart distribution has been envisaged by the central for avoiding such interruption and duration of the interruptions. So both can be improved with the smart system.
Okay, sir.
Yeah.
Also, another question that I had, so during now I will lockdown.
Yeah.
Everybody received a lot of bills. I mean, to the order of 20,000, 25,000, etc. Now, if this is so smart device controlled, I mean, IoT based, like you said, you know, all the meters are there, then such kind of things should not happen actually, right?
Yeah, you said very correct, and henceforth you might have articles that smart metering is very important, and it is not been introduced at every places, but it is in the process that within another 2 years, all consumer will have smart metering. Okay, you see at your home, and frankly speaking, we have proposed to the cabinet minister also that smart it should not be restricted to the distribution company. The reading should be available to the consumer also. That type of presentation 2 months before to the cabinet minister also. Okay, so what will happen that whatever the consumption happening at aware of it, and whenever you are receiving the bill, you are very much knowledgeable in advance that you have really consumed, so very confident to pay it without any hesitations. So you said very correctly, and henceforth smart metering will, and smart metering will include also remote cutoff also, that if you don't pay the bill, then they can cut off your power. Like what we have described in our distribution transformer, from the central place, the outgoing of the distribution transformer power can be switched off sitting at the central control. Similarly, your power at your residence power can be cut off also from the remote place. Okay, we are also envisaging that intelligence should be there, but it is not being till today not in the specifications, that if any okay or earthing is not proper, that also to be sensed and to be provided to the distribution authority, so that they can recommend that your earthing should be improved. But it is little it's a cost addition. So with smart, too many things can happen, and henceforth is today people that everything, everybody's talking about the cost, but cost is gradually reducing and everything becomes smart. Within 2-3 years, I think time will change actually in water distribution as well as the energy distribution. That is very sure.
Thank you, sir.
Please. Yeah, any question? Yeah, I would like to add one point that if I think we have 10 minutes more, 5-10 minutes more, or we should close.
Yes, sir, we have time.
Okay, okay, fine. So once I was answering, I was tempted to just extend the same thing for 5-10 minutes for the management system with IoT actually. So many of you have traveled across the globe and US, Australia, or European countries, what I understand. Okay. So their water distribution system is to the extent smart. Whenever we talk about the smartness in the system, means again key performance indicator has to be kept in mind. I will be talking about the availability of the power, reliability of the power, and interruption of the power. That should be improved, and as for the smart, if it is smart, it is improved system everywhere. People in US, even when I went Germany, I asked. So he said, the water in the tap is drinkable water, and you can drink it. That to you. So we were involved in 2-3 years before. We were involved water distribution management project, and just I would like to describe what was the key objectives for the systems. So as per the national standard, international standards, that whatever water you should be having pressure of more than 8 bar, 8 kg, 0.8. This water should reach to minimum your 5th floor. Okay. It is not happening in India at this moment, but it is supposed. So why pressure? So full system should be pressurized. Second part, that automatically in the pipelines, distribution pipelines. Okay. Third, metering to be happen automatically, billing to be happen, and availability of the water should happen 24 hours. Now, this much of the key performance indicator what I have described are being published. So World Health Organization is today or in past very much concerned with the purity of. So So in that case, what they have described, that water should be pressurized and it should be 24 by. It should not be interrupted, and there should not be leakages in the pipeline. So water is treated. That is, whatever water every citizen is getting is treated water. So another part, that the water is available at certain junctions in distribution to be analyzed automatically, and data of the water purity should reach to the central distribution. So you can see that the key performance indicator, what is expected by the double, is very, very important but difficult to manage. So now smart water distribution system, all what has been described. But why they have kept, if water is filled in the pipe, and if there is a leakage, then there is ingress of the all external inside is filled in, then what will happen? Water will go outside, nothing will come inside. If some drainage system is going by close by to the water system, that get into the potable water system. So if it is pressurized, water will go out. So WHO has consumer, every my resident should have enough pressure so that no ingress should happen through the pipeline. So is being designed, developed, and it is introduced at few cities in India also today with the IoT. So just I was adding that the any solution there has to be key performance indicators, and all indicators, and the solution is provided. Then the ideal performance is achieved. Actually, expected performance is achieved. So today again, from industry perception, as I described in the beginning, there are smart buildings. What we have done, we have provided the smart homes. We have provided smart home in Gujarat, more than 500 bungalows and apartments also, and smart homes also having many more facilities for the people staying in the home. So today we are with the smart energy, but smart energy in smart distribution system. In this session, we will be describing the smart energy in renewable energy scenario. Reading in the newspaper or many more news. India, trying to be more independent in the power, and that too, they would like to reduce the fossil fuels and more dependent on the renewable energies. So, introduction in renewable energy, how disturb the existing system, and how it can be controlled, and how it can be more make reliable with the smartness in the renewable energy. We will be discussing later on today. So I would like to close this session at this moment if there is no question. And thank you very much for being with me. So shall we close?
Okay, sir.
Yes, sir.
Okay, sir. Thank you, sir.
Okay.
Thank you,
Thank
sir.
you.
Thank you. It was very informative.
Thank you very much.
sir.
Thank you so much, sir.
Thank you very much. Thank you. Thank you. Thank you very much.
Dear participants, we are resting for a lunch break here, and we will again meet at 2 p.m. for post-lunch session. Gandhi sir, 2 p.m.
Okay, fine. See you then.
Okay.
Bye.
Okay, sir.